Hi everyone! In today's video I will be going over the 5-1 practice test, otherwise known as our 5-1 review. When I go through these problems, if I find that there is a possible second way to do it, I will show it to you. I will do up to 2 ways per problem. Some problems might only have 1 way. Now, most problems can be solved 2 to 3 ways, some even 4. So just because you didn't solve it exactly how I solved it doesn't necessarily mean you are incorrect. It just means you might have found one of the other ways that I didn't show you. When I'm going through these, I'm going to kind of color code my options, my different ways. So my go-to color is purple, so the first way I do it will be in purple, and then if there's a second way, I'll do it in green. All right. First problem. Number 1. It is cotangent x times cosine x tangent x plus sine of x. Now option 1 will almost always be what I consider the faster way, or the way that I would do it if I were personally doing the problem. So if it were me, I would distribute the cotangent into the parentheses. And you want to do this carefully. When you distribute the cotangent, it goes to both of these like as one whole. They're one term. So I'm not going to multiply it by the cosine and the tangent. It's just one thing. It's basically going to join them. And then I'll separately multiply it by the sine since it is a separate term. So how that would look, and you can put it anywhere you want. Technically, you should go after the cosine, but it really doesn't matter. Just kind of smush them all together because that's what we do when we multiply trig functions. Plus cotangent x sine of x. Now these are all being multiplied here, so if you are already looking out for reciprocals, some of you may notice, oh, I've got cotangent and tangent, those will cancel. If you don't notice that right now, that's fine. What you would hopefully do instead is rewrite everything that's not a sine or cosine in terms of that. So we're going to rewrite these as cosine over sine. This is just cosine, but I will turn it into a fraction to make this look easier. And then this is sine over cosine. Plus, and then cosine over sine. And then sine over 1. Now let's see what canceling I can do here. Now make sure you only do it within your multiplied groups, so I can't cancel from here to all the way over here, and vice versa. So we have cosine on top and 1 on bottom, so I can cancel out 1 each. And then I have a sine on top and bottom, so those will cancel. Those will all become 1s when I'm multiplying. Don't really have to worry about that. So all that's left is this cosine over 1. I'm going to not leave it as a fraction. I think that would cause more confusion. So I'm going to take it out of fraction form since it's just cosine. Plus, and then we'll do the same thing over here. I've got a sine on top and bottom, so those cancel. So if I were to multiply, these would just become 1s. So that's just cosine. All right, cosine x plus cosine x. A lot of you think that this would be cosine squared, but that is incorrect. Remember, and let me take this back to basic x's, because if we can understand it at that level, we can definitely understand it here. X times x is x squared. X plus x is 2x. Same thing here. Cosine x times cosine x is cosine squared x. So cosine x plus cosine x is 2 cosine x. Basically, we're saying we're adding them together. We got 2 cosines here, so 2 cosine. So that is going to be the answer to this problem. So that's option 1. I'm going to show option 2. I will attempt to do this as side by side as well as I can from what I can show. Option 2. I saw this a lot in class, and I actually really like this option as well. It actually avoids some errors in other places. Okay, so we're going to start with our original problem again. Cotangent x times cosine x tangent x. If you understood option 1 well and you're like, yes, that's exactly how I would have done it, go ahead and skip on to the next problem in the video. You do not have to sit through this if you don't want to. All right. What other people did is right out of the gate, they went through and changed all of these to their alternative forms like we did here by the third step. So this becomes cosine x over sine of x times cosine x over 1, and I do recommend parentheses here. Tangent is sine over cosine. Plus, I'm going to turn this into a fraction as well, sine of x over 1. When you're working with fractions, there are times where it helps to turn everything into a fraction, just so visually you can keep track of what you're doing. Now, I don't recommend distributing at this step. If you can't already see, there are some extra things I can do inside the parentheses, so let's do that first. So I've still got cosine x, sine x hanging out outside here. Now I've got a cos, looking at just this group here because they're being multiplied. I'm ignoring the right side right now. Cosine on top, cosine on bottom. Those become 1s. So all I have left here is just sine, which I will take out of fraction form now. And then this plus sine over 1, I'm going to rewrite this as just a sine as well. If you wrote them as fractions, you'd kind of quickly realize there's not much you can do with that, so you would probably return to this form. Now, some students would be tempted to distribute here. That's fine. But we can make this even simpler by not distributing yet. So, we have cosine x over sine of x times, I already explained this earlier, sine times sine is sine squared. Sine plus sine is 2 sine x. Now, since I have a fraction, I will return this to fraction form because my last step would be to just multiply these. So we've got a sine on top and a sine on bottom. Don't worry so much about the 2. It's just like having a constant on the front of an x or some other letter. It's just kind of there, and you carry it with your work. So these turn into 1s. So basically, we just have cosine times 2 on the top and then 1s on the bottom. So cosine times 2 is 2 cosine x. That's another way to do the problem. Now, obviously, it took a couple more steps than option 1, so to each their own, but we still got there, and it was a different way of thinking. So whichever way works for you. Okay, number 2. Cosine of x minus cosine of x sine squared of x. This is a good problem. This is one where we will definitely be split on which way is better, which way makes more sense. Definitely have some different opinions on that. So again, option 1 is what I would do personally. That doesn't mean it's wrong. That's just the way I see it. So when I look at this, automatically I notice that I have a GCF here. I've got my 2 terms. They both have cosine, so I can take a cosine out of there, factor it out. What's left? Cosine divided by cosine is just 1, minus, this disappears, so I just have sine squared x left. And then 1 minus sine squared, you should recognize that as a Pythagorean identity. It's equal to cosine squared x. And then cosine times cosine squared, remember, that's going to be like adding exponents. That's going to get us cosine cubed. x. So that's one way to do it. As you can see, it's extremely quick, but a lot of students will miss the GCF. They won't see it. So let me show you the other way that I saw a lot of students doing instead. And this way is just as valid, by the way. All right. Cosine of x minus cosine of x, sine squared of x. The other way to go about the problem is, notice you have a sine squared. Whenever you see a squared, you have a Pythagorean identity. So let's replace the sine squared of x with its Pythagorean identity. Reminder, on the test, you will not have all possible rearrangements of this provided to you. You will have just the original equation, which is sine squared x plus cosine squared x, almost wrote plus 1, equals 1. So, remember, this is just a rearrangement. I want to know what just sine squared is. So, if I had to rearrange the equation, I would move the cosine squared over here to get the sine squared by itself. I would obviously do that by subtraction. So that gets me 1 minus cosine squared x. I strongly recommend, even if you feel like you have it correct in your head, write this out and make sure you do the algebra correctly, because even flipping these two around completely changes your answer if you do it mentally. If you do it on paper, you shouldn't make this mistake. And obviously, if you flip the 1 and the cosine squared, it is wrong, by the way. So I'm going to replace the sine squared x with that 1 minus cosine squared x. And then we have a little bit of algebra to do. We can distribute the cosine into the parentheses. So we get cosine of x minus cosine of x. Careful, minus, minus, that's a plus when you multiply them. Cosine times cosine squared is cosine cubed. And then what's nice is we got a cosine minus cosine. Those do cancel. And we're left with our final answer, cosine cubed x. And that's it. As you can see, neither method is necessarily faster. The option 1 was a bit faster, but they don't take that many steps either way. So you can't go wrong with either one, whichever one makes most sense to you. All right, number 3. Number 3 is not fun, just warning you now. And this one, I'm actually going to do it vertically because of how much space it takes up. Number 3. 1 plus cosine of x over sine of x minus sine of x over 1 plus cosine of x. Okay. So option 1, and if I'm thinking of the correct problem, like how it works out, there's how you start it is going to look the same for both options. So I'm not going to show full out option 2. I'm going to show you where the step can change depending on the person. And then I'll go from there. But I won't do all of the work, if that makes sense, because then we'll be here for longer than we need to be. So the start's going to look the same regardless of which way you choose. All right. So first things first, you have 2 fractions. A goal is obviously to always get common denominator since we're subtracting common denominator. So let's do that first and foremost. Common denominator will just be sine of x times 1 plus cosine of x. So I'm going to multiply them by each other. Multiply the left fraction by 1 plus cosine of x on top and bottom. And since these are expressions, I'm going to write these in parentheses. So I'm multiplying top and bottom by the other denominator. Now, a reminder, do not cancel these out. That is very tempting. That would just undo the work I just did. Minus, now the other fraction needs to get multiplied by the other denominator, sine of x. So we have sine of x times sine of x over 1 plus cosine of x times sine of x. Don't multiply your denominator. I don't think I'm going to actually do that at all. Reminder, you don't know whether putting these together or leaving them separate like I have them right now, how that's going to benefit you in the future. So when in doubt, leave them like this, and then if we have to multiply later, we'll multiply later. All right. Next thing we're going to do is we're going to do the algebra on the top. So these I'm going to have to FOIL. So first I've got 1 times 1, that's 1. 1 times cosine, that's cosine x. Cosine times 1, that's another cosine x. And then cosine times cosine, that's cosine squared x. And then I'm going to go ahead and write this as one big fraction just to save me a step. Minus sine times sine is sine squared x. And then again, don't multiply these together. When you combine them, you only write the denominator one time. Sine of x times 1 plus cosine of x. All right. From here, I do have two like terms I can combine, cosine and cosine. Add them together, you get 1 plus 2 cosine x plus cosine squared x minus sine of x. Sine squared x, sorry. All over that denominator. Reminder, make sure you carry that denominator the whole time. I know a lot of you like to kind of just do the top for so long, which I understand because we're not really changing the bottom, so it is tedious to keep writing it. But some of you will leave it up here and forget it, and then it changes your answer. All right, here's where it gets tricky. This one's not the funnest one, I'm going to say that now. You have two options. First off, a lot of students see this cosine squared minus sine squared and like, oh, that's 1. Nope. Let me find my previous paper. The original Pythagorean identity is sine squared plus cosine squared, not minus. In fact, there is no way to get that to be cosine squared minus sine squared from this equation. Because if I make one of these negative, I have to make the other negative. If you don't believe me, play around with it. I promise you it will not work. So this is not an option. You have two options, and here are your two methods, if you will. So, and I can't really say which one's better than the other. We'll see how they play out, and then we can make a decision if you'd like. The first way to do it is you can move the 1 over here, because one possible rearrangement is 1 minus sine squared. That is cosine squared. I'll write that on the paper up here. So again, we have sine squared x plus cosine squared x equals 1. So if I move the sine squared over, I get cosine squared x equals 1 minus sine squared x. So that is one option I can use. So I'm going to rearrange the terms a bit. Now I have 2 cosine x plus cosine squared x. Now I'm going to move the 1 behind it, plus 1 minus sine squared x. And then over my denominator, please keep writing it. Okay, so now what I'm going to do is I'm going to mentally block this off, and I'm going to replace that with the cosine squared that I just discovered up here. So now I have 2 cosine of x plus cosine squared x. Now I have another plus cosine squared x over denominator sine of x times 1 plus cosine of x. We are almost done. We can combine like terms. I've got 2 of these cosine squared, so when I add them together, I get 2 cosine of x plus 2 cosine squared x over my denominator. Now, unfortunately, on this problem, if GCF did not jive with you on the number 2, unfortunately, you have to pull out a GCF on this problem. I do not believe there's a way around it. Looking at your terms on the top, they both have a 2 and a cosine, so that's my GCF. 2 cosine of x, I'm going to take that out. For the first term, when we divide 2 cosine of x by itself, that leaves 1 plus 2 cosine squared divided by 2 cosine is just a cosine over sine of x, 1 plus cosine of x. And here we can finally do some damage. I've got 1 plus cosine on top and 1 plus cosine on bottom. This is multiplication here, yes, so canceling is allowed. Now we have 2 cosine of x over sine of x. Notice I kind of wrote the 2 next to it. When it's on top, it can also go in front of it. So kind of visually separate these for a moment. Cosine over sine we recognize as cotangent. And then that 2 is just going to go in front of it. That is the correct answer. Lot of work. Option 2 isn't going to save you much time. It's just another way to do it. So I'm just going to tell you now. All right, option 2. Reminder, the beginning is the same. Where it changes is at this step here. We can do something else besides removing the 1 over here and replacing the 1 minus sine squared. So let me show you option 2. So again, same steps. Steps 1 through 4 are the same. Going to block that off. So, if this is option 2, so you have to be able to start the problem that way because I have not found a different way to do it. Okay, what we're going to do differently is instead of moving the 1 over here and using this Pythagorean, we're going to use a different Pythagorean. What we'll do differently is we will instead replace this sine squared x with its Pythagorean identity. So I'm going to write that out by itself, and then I'm going to block off in parentheses what I'm going to change. So we have 1 plus 2 cosine of x plus cosine squared x minus sine squared x over the denominator, sine of x times 1 plus cosine of x. And then I'm going to block off what I'm replacing. Now keep in mind that minus is outside of there. You need to be careful with it in this next step. So that is a downside to doing it this way, is if you forget how to properly handle the minus, it can cause some problems for you. All right, sine squared x. If I go to my original equation, which was sine squared plus cosine squared equals 1, sine squared, if I get it by itself, I'm going to move the cosine squared over here, is 1 minus cosine squared. So I'm going to replace my sine squared with 1 minus cosine squared. So I have, I'm trying to align these up a bit. It's not going to happen. 1 plus 2 cosine of x plus cosine squared x minus, now I'll replace, and I'll actually do that in red just for emphasis, 1 minus cosine squared x. That's my new piece over that denominator. All right, from here, you need to be careful with that negative. Remember, treat it like a -1 and distribute it inside. That's exactly what I'll do. 1 plus 2 cosine of x plus cosine squared x. Let's Distribute that, that becomes a negative 1. And then distribute it, this becomes a positive cosine squared x over my denominator. Sine of x, 1 plus cosine of x. All right, let's see what like terms we can combine. We have a positive 1 and a negative 1. Those will cancel. And then we have 2 cosine squareds, just like we did previously. So actually, we're basically at the equivalent of this step here from option 1. My next thing that I write is going to be exactly what I have here. 2 cosine of x plus, and then I'm going to add these together to get a cosine, 2 cosine squared x over sine of x times 1 plus cosine of x. From here, my steps are going to be exactly what I did over here. So I'm going to just rewrite all of that. Once again, you pull out the GCF of 2 cosine of x, and that leaves 1 plus cosine of x over sine of x times 1 plus cosine of x. Cancel, cancel. And then we get 2 cosine over sine, which is again 2 cotangent. And I just realized I did all of that in purple when I meant to do that in green. So again, this is all option 2. Sorry about that. So option 2, still in purple, my apologies. But yes, this was option 1, option 2. As you can see, the problem that I did from option to option didn't change a whole lot. The first 4 steps are exactly the same. I changed which Pythagorean I used, and then it still came out to the exact same results down to the work. So really, it's just whatever you saw in the problem. All right, that was number 3. That was one of the longest problems on the study guide. The others, quite a few of them are a bit shorter. All right, number 4. And I'll do this one. No, I'm not going to fit it there. This is vertical as well. This one's going to be lengthy as well. Number 4. 1 plus cosecant x over secant x minus cosine of x. All right. I don't know if there's going to be an option 2 on this problem. We'll see if one comes to me as I go through it. This one's pretty lengthy, so it will be difficult to have multiple options, but we'll see. So I'm not going to write option 1 yet until I know for sure. 1 plus cosecant x over secant x minus cosine of x. Notice we have a fraction here, but we don't have a fraction here. So probably beneficial to go ahead and write this as over 1 because we will eventually need a common denominator, and that's exactly where this is going to go. So first, let's handle, actually, yeah, okay. I'm going to do option 1. Option 2 is already coming to me as I'm talking, and I don't want to throw myself off, so we'll revisit that. Okay. So what we can do here is we can get this down to something easier and then find a common denominator. Actually, I'm going to go and get a common denominator now. I have a feeling that this is going to be a much easier solution than what I have. So we have secant and we have 1. Obviously, a nice common denominator would be secant. So let's multiply this fraction, top and bottom, by secant. Okay. And then we have 1 plus cosecant x over secant x minus cosine x times secant x over secant x. Hopefully you notice that this is a reciprocal pairing, so this will in fact be 1. But if you don't notice it, we can change it. Actually, you know what? I'm going to cancel it. It's going to make myself feel better. Cosine, secant, they are opposites. They are reciprocals. You give 1 minus 1 over secant x. Yeah, I'm not going to show you the other way I was going to do it. That is far more complicated. I don't know what I was thinking at the time. Okay, 1 plus cosecant minus 1. We have a 1 minus 1, so those are gone. And then we have cosecant x over secant x. Well, at this point, we have no other option besides converting these to their sine and cosine forms and then figuring out where that takes us. So cosecant is 1 over sine, we know that, over secant is 1 over cosine of x. I've said this multiple times before, I'm not going to keep saying it. There are tricks around writing out keep, change, flip, but I strongly recommend you do not use them. A lot of students will mess this up because they don't write it out fully. Just take the moment to write out keep, change, flip, and make sure everything works out like you're thinking it will, because sometimes it doesn't, and then you get the complete wrong answer. And that's not good for anyone. All right. So I'm going to write this out. And I'm going to take an extra step to do this because I still have students messing up keep, change, flip. But if you don't need this level of work, don't do it. But this is literally 1 over sine divided by 1 over cosine. So I haven't done keep, change, flip yet. I just changed this into a regular division problem. Now we keep the first fraction the same. Change the division to multiplication. Flip the second fraction. Multiply straight across, we're not cross multiplying. This is cosine of x over sine of x. And you can't leave it that way, it's a fraction. We know cosine over sine is cotangent. And we are done. I will not do an option 2. That was a great option that I just did now. I'm really happy with it. So there's not another one coming to me. The one I was going to do was how I did it earlier, and it is far more complicated than I needed to make it. So this is a good way. All right, number 5. Verifying problems. These are problems where, as long as you're doing legal steps, and I call them legal steps because they have to be correct steps, things you're allowed to do. As long as you're doing legal steps, you can eventually get to the right answer. 1 plus 1 over 1 plus sine plus 1 over 1 minus sine squared equal sine of x. Goodness, I am reading things that are not there. Equals 2 secant squared x. I'm pretty sure there's an option 2 here. I'm just debating on whether I want to show it to you because it might be far more work than necessary. We'll see. I'll just show you the main way right now, and we'll go from there. Okay, so I'm going to rewrite the problem. I do recommend putting these in parentheses. Now reminder, we're just trying to get the same thing on the left and the right sides, so we're not moving things over the line. So this is your friendly reminder to not cross the line. Okay, so the right side, we don't have a ton to work with. I could change this to 1 over cosine squared, and depending on the person, you might do this, you might not. But I clearly have far more work I could be doing on the left side, so let's start there. Anytime you have 2 separate fractions, let's figure out how to get them into one fraction. We're adding fractions here, so that means we have to have a common denominator. So I'm going to multiply each fraction by the other denominator. So this is going to be, I'm going to write this smaller for sure, just an FYI. Multiply the left by 1 minus sine of x on top and bottom. plus, I'm going to multiply the right fraction by 1 plus sign on top and bottom. Okay. From here, I now have the same denominator, so I'm going to actually add the top. If it helps, write this as one thing before you start combining like terms, if this helps you see it. So that's exactly what I'll do. 1 minus sine of x plus 1 plus sine of x over. Now remember, common denominator, you only write the denominator once. Now I'm going to go ahead and tell you, you will need to FOIL this out to get to your correct answer. So I will also do that going to the next step. If you recognize what this is, you could actually get an answer pretty quickly. This is a difference of squares set up. So I can already imagine what my answer will be, but if you don't catch it, that's fine. 1 times 1 is 1. 1 times negative sine is negative sine x. Sine times 1, that's just going to be sine x. And then positive sine times negative sine, that's negative sine squared x. From here, I've got like terms on the top and the bottom. By the way, don't be that person to go ahead and start canceling things. No, This is all subtraction and addition on the top and the bottom. You can't cancel through those. Okay, let's see what we can cancel on the top. We have 1 plus 1, that's going to become a nice 2. And then we have negative sign and positive sign. Those will cancel. So on the top of the fraction, we only have a 2. On the bottom, we have 1 minus sign plus sign minus sign squared. The minus sign and plus sign do cancel, leaving us with 1 minus sign squared. And then I am almost done. 1 minus sine squared, that is a Pythagorean. Hopefully you recognized it. I can replace that with cosine squared x. I did that just a moment ago. If you have sine squared plus cosine squared equals 1, then 1 minus sine squared is equal to cosine squared. So that's what I just did. Lastly, if you get here and you get stuck, remind yourself of what your goal is, 2 secant squared x. Well, that's exactly what 2 over cosine squared is. And I can write this out as an extra step for those of you who don't see it. Remember, this 2 can kind of be set aside and written as 2 times 1 over cosine squared x. Because if I multiply this back together, I just put the 2 back on top, because it's 2 over 1. 2 times 1 puts the 2 there. So, and we know cosine squared is 1 over cosine squared is secant squared x. Bring that 2 down in front. And then that was my goal. So I'm just going to bring this all the way down here. Make sure you're checking in with yourself periodically to make sure that you're on track, that you haven't already reached your goal. Those kinds of things, just to help keep you motivated in knowing where you're going with this. There aren't any major other ways you could take this problem. Another way you could, and I'm not going to write this out, but just kind of speaking aloud here. Something you could do is you could have stopped here and then just rewritten the secant squared as 1 over cosine squared, and then just had 2 over cosine squared on the left and the right. That could have been another way to do the problem instead of fully changing this into secant squared. But that's the only thing coming to mind right now. That would be an option too. Otherwise, this is pretty much how you'll solve the problem. All right, number 6. Secant squared x minus 1 over secant squared x equals sine squared x. This problem has quite a bit of leeway. It definitely has some options, so it really just depends on the person. And I actually think I will go ahead and show both ways for those of you who are curious. All right, option 1. Now, if I'm thinking about this clearly, this will not be the easier or the quicker option, but it will be the way that most of you will do the problem. So once again, I have secant squared x minus 1 over secant squared x equals sine squared x. Reminder, don't cross the line. All right, so most of you would think to use your Pythagoreans on here, and you'd be correct. Let's make sure we're on the same page about which Pythagoreans. So, the main equation for this with the secant squared is 1 plus tangent squared x equals secant squared x. So, we can use either form of those. When you're working with a fraction, and again, it genuinely just depends on the problem, more likely than not, it's better to have one thing over another. Here we have 2 terms on the top, so that's going to make our work a little longer than we'd like it to be. So I want to change just the top. Don't change both for sure, and don't change, changing the bottom will cause you more work than it's worth. So I wouldn't change the bottom, change the top. So we need secant squared minus 1. Well, I've already got secant squared over here, so if I move the 1 over here, I'll get secant squared x minus 1, and then I just have tangent squared left. So tangent squared is what this is equal to. So I'm going to put that in red. So now this is tangent squared x, that's it, over secant squared x. Next, our only option would then be go towards the sine and cosine forms of both of these functions. So tangent is sine over cosine, don't forget the squareds, over secant squared is just 1 over cosine squared. Then we can keep, change, flip. I'm going to do this in one step. Sine squared x over cosine squared x. Please write this out. So top fraction times, we're changing this to times, flip, cosine squared x over 1. Cancel, cancel. We are left with sine squared x, which is exactly what I needed to get. I'm going to bring this down. And there you have it. All right, option 2. Some of you probably never in a million years would have done this, but it is a nice trick, and it will be a tad faster than the one I just showed you. And I actually really like how this works out. So, if anything, this is just neat to show you. Okay, option 2. Secant squared x minus 1 over secant squared x equals sine squared x. And then we're going to draw the line again. Reminder, don't cross. Okay. The other way to do it. Remember, when you have fractions, I'm going to try and find a quick example of what I'm about to show you here. Although I just did on number 4. So, you know how you have 2 separate fractions, and then you could turn them into one fraction. You can go backwards. You can take one joint fraction and separate it into 2 if you are adding or subtracting on the top. We are subtracting on the top, so I can write this as 2 fractions over the same denominator. Secant squared x over secant squared x minus 1 over secant squared x. This is very easy to misuse, so I don't always show it, but it is a really neat trick, and it's going to work out very nicely in just a moment. So, if you do this, just do a quick check. Ask yourself, if I put these back together, will I get the same result? Secant squared minus 1, that would be that on the top, and then the denominator is the same. Yes. Okay, the reason I'm doing this, secant squared divided by itself, well, that's going to cancel and just give me 1 minus 1 over secant squared is cosine squared x. And then you should recognize this. This is a Pythagorean identity. And I'm going to show you from number 2 when I used it. Sine squared plus cosine squared equals 1. And then sine squared is equal to 1 minus cosine squared. So I'm going to replace this 1 minus cosine squared with sine squared. So that's going to give me sine squared x. And then look, that's exactly what I needed to get. So most of you probably didn't think of that, but that is another way to do it. It's actually really neat. And it is just a tad less work than option 1. And I didn't have to do keep, change, flip, or anything weird with the fractions. So this is another option to consider as well. If you're going to use that fraction trick of splitting it up, make sure you're doing it when you have addition or subtraction on the top, not the bottom, the top. If you just have one term up here, it's not an option, unfortunately. Just an FYI. Okay, that was number 6. 2 more of those, and then the quick ones. This one I think is a quicker problem, if I remember correctly. Number 7. Cotangent x plus tangent x equals cosecant x secant x. Remember, these are being multiplied here, just an FYI. I'm not sure yet if there's an option 2. We'll see if one comes to me as we're working. So for now, I'm just going to show you one option. So we have cotangent x plus tangent x equals cosecant x times secant x. Reminder, don't cross the line. That just means no algebra steps, no moving things back and forth. Okay, we have options. One good place to start, and we can just do this across the board, is change everything to be in terms of sine and cosine. So cotangent is cosine over sine. Tangent is sine over cosine. Cosecant is 1 over sine. And secant is 1 over cosine. All right. On the right side, we're multiplying, so you just multiply straight across. 1 over sine of x, cosine of x. And then on the left side, be careful, we are adding here. We need a common denominator. So we're going to multiply each fraction by the other's denominator. So we have cosine of x. We're going to multiply that fraction by cosine times cosine over sine of x times cosine of x plus, and then I multiply the right fraction by sine over sine. Sine of x times sine of x over cosine of x times sine of x. I'm going to simplify this. Cosine times cosine, that's cosine squared x, plus sine times sine, that's sine squared x. And then I'm just going to go ahead and make this one big fraction over just the denominator one time. Sine of x times cosine of x. Go ahead and bring this down. Hopefully you see where this is going next. We are basically done. This is a Pythagorean identity. It is the general equation. Sine squared plus cosine squared equals 1. Flip-flopping that order does not make a difference. So we're going to replace that with just 1 over sine of x cosine of x equals what I have on the right side. 1 over sine of x cosine of x. And that is my answer. I could also see, I've seen this a few times, students could re-separate these and turn them into cosecant times secant if you didn't want to do this fraction work here. I typically would not recommend it. Again, that's something that's very easily messed up. So I would not recommend that at all. I would just recommend the way I showed you. So it looks like this one's going to have only one option. Number 8. Just curious how many steps it is. Okay, I can't find it. We will find out if this is a long or a short problem together. 8 is cosecant x over sine of x minus cotangent x over tangent x, and that will be equal to 1. Here's the good news. First off, I don't know if option 1, option 2, we don't know yet. It's just one option or two options. I will let you know. The good news is the right side's just 1, so we know what we need to get over here. There's no work to be done on the right side. Reminder, do not cross the line. No algebra steps to the left or the right side, like moving one thing to the other, for instance. Don't cross. Okay, so we need to get this to be a 1 somehow, some way. Okay. First thing we can do, again, we have options here. And again, this is where option 1 versus option 2 would come in. You could try to work these fractions out separately first, or you can try or you could get a common denominator and work with that. I'm going to do that first. Get a common denominator and see what happens. Common denominator would obviously be sine times tangent. So I'm going to multiply the left fraction. Cosecant x times tangent x over sine of x times tangent x minus right fraction multiplied by sine over sine, cotangent x times sine of x over sine of x times tangent of x. All right, I'm going to rewrite everything in terms of sine and cosine to make this easier. Cosecant is 1 over sine of x. Tangent is sine over cosine. And then sine times sine over cosine minus cotangent is cosine over sine times sine, and I'm going to put that over 1. Let me actually do that down here as well. Over, and then the denominator will obviously be the same. Sine of x over 1 times sine over cosine. Okay, now let's start canceling. Do not cancel this sine over cosine with this sine over cosine. It seems like you're doing work, you're not. You're going to put yourself back where you started. You don't see it now, you will eventually. So, we multiply by tangent over tangent for a reason. Don't cancel it out. So, just going to cancel on the tops. So we got sine over sine. That's going to be 1 over cosine. And then we got sine over sine here. That is going to be cosine over 1. Now, on the bottom, I can cancel just with the bottom, though. There is no canceling to be done here. But when I multiply, this will become sine squared over cosine. I'll keep that in mind. So let's write our new fraction as one thing. Actually, no. I'll take another step. Why not? So this is 1 over cosine of x over, this becomes sine squared over cosine, minus, this is just cosine of x over, once again the denominator is going to be the same. We intended for that to happen. Okay, now that we've got same denominator, we can write this as one fraction. 1 over cosine of x minus cosine of x over 1 over, sine squared x over cosine of x. Okay, we're almost done. We're a few steps away, but we're getting there. Okay. I already see we are going to have an option 2 because I can see a better way I could have gone about this, but we're just going to stick with it. All right. You can't keep, change, flip until this is one fraction, not 2. So we need to somehow get this down to one fraction. So I'm just going to save myself a little bit of space and work here by going ahead and showing you what I'm doing next. Obviously, we need the common denominator to be cosine, so we're going to multiply top and bottom here by cosine of x over cosine of x. So that's going to give me 1 minus cosine times cosine is cosine squared x over, that's going to be a cosine, so on the bottom my denominator is cosine, over, this is sine squared x over cosine of x. Okay, I promise I am done. Basically done. All right, I'm going to go horizontal because I'm basically done with the problem. 1 minus cosine squared, you should recognize that's Pythagorean. 1 minus cosine squared is equal to sine squared. So I'm going to replace that with sine squared x over cosine of x over sine squared x over cosine of x. There's no need to keep, change, flip this. We have the same fraction being divided by itself. Anytime you divide something by itself, it's always going to equal 1. Okay, and we have done it. So let me bring my line down that I kind of left behind because my work was getting a little crazy. And then on the right side, I just need a 1. I knew that the whole time. So it was a lot of fraction work to get here, for sure. Okay, I'm going to show you option 2. It's a small change. Yeah, it would have saved me about 2 steps, and I think a little bit of a headache too. So let me show you option 2. And I promise it'll be quick because most of the steps are going to repeat themselves. So I'm actually going to start pretty much just where the option 2 starts. So I'm going to do this on a separate piece of paper. So we do end up having option 1 here. And so this will be option number 2. Okay, so for option number 2, I'm not going to change anything until I get to this step right here. So again, these are all going to be the same. Same steps. Are there things I could change? Yes, but I wholeheartedly believe the way I went here, as long as the problem as it is, I did go the shortest possible way. So I'm going to make change at this step here. I'm going to go ahead and write it out. Yeah, try to fit all of this. There we go. So we have 1 over cosine of x over sine squared x over cosine of x minus cosine of x over sine squared x over cosine of x. All right, instead of trying to get common denominator, or not even just common denominator, I do have common denominator. Instead of combining and getting common denominator on the top, let's keep, change, flip both of these. It's going to make my math so much easier. So I'm going to do keep, change, flip twice. Okay, I have to take this out of view, unfortunately, to do that. So this side becomes 1 over cosine of x, top, keep, change to multiplication, flip the bottom, cosine of x over sine of squared of x, minus, and then I'm going to keep, change, flip this, cosine of x over 1, keep, change to multiplication, flip to be cosine of x over sine squared x. Over sine squared of x. Okay, now I need to handle these separately. So I can do a little bit of canceling. Cosine on top here and cosine on bottom here, cross out because I'm multiplying, I can do that. This leaves 1 over sine squared of x minus. Now that can't cancel over here, so I'm just going to multiply. Cosine times cosine is cosine squared x over sine squared x. And then 1 minus cosine squared we just discussed is sine squared x over sine squared x, which does equal 1, which is what your equation is supposed to equal. So we got 1 equals 1. All right, that didn't save as much time as I thought it would, so I probably wouldn't have shown you that, but hey, why not? It's just extra things to think about. So that's just ultimately another way. I think it saved a small bit of headache and fractions, but not really. So again, option 2 was the same steps, and then when we got here, instead of subtracting the fractions and then getting another common denominator, I just keep, change, flipped both of them, simplified, and then was able to get a nice answer pretty quickly. So that's an option. Once again, that's the type of problem that's just, you'd rather not do one like that, but you need to be able to do some of those as well. Okay, the bottom 7 problems, numbered 1 through 7, these are quick. So all you need to be able to do is basically just recall these off the top of your head. So, number 1, sine squared plus cosine squared, that's equal to 1. That is a basic Pythagorean identity. It is not rearranged at all. By the way, this portion of the test would be the portion done without the reference sheet, just so you know, because pretty much all of this is on there. Sine times cosecant, you should recognize those. They are reciprocals, so they do equal 1. If you're not at this stage yet, remember, you can break this down and write sine of theta times cosecant theta is 1 over sine theta. And then notice, oh, they cancel. That's 1. Do that if you have to. Cosecant squared theta minus 1. I'm going to write out the regular form of that equation because this is rearranged. The general equation is 1 plus cotangent squared theta equals cosecant squared theta. So if I want to figure out what cosecant squared minus 1 is, I have to move the 1 over here. So I subtract it. Cosecant squared theta minus 1. So cotangent squared is what that's equal to. All right, cosine squared m over sine squared m. First off, cosine over sine, you should recognize that. That is cotangent. So we've got cotangent here. They're both squared, so my answer is squared. And then on top of that, our letter here is m. So it's just cotangent squared of m. 1 over tangent x, that's a reciprocal. You should recognize it. It's cotangent x. Tangent and cotangent are reciprocals. Cotangent beta, sine beta. This is a trick one where people will be like, oh, they're being multiplied, therefore it's 1. No, this is not 1. So again, this is one you'll have to write out. cotangent is cosine beta over sine beta times sine beta over 1. Cancel the signs. You are left with cosine beta. Last but not least, 1 over cosine squared beta. 1 over cosine, hopefully you recognize that as secant beta. But since it's squared, this is going to be secant squared beta. Slight change. All right, that is all for this video. I promise you, between looking at this versus the test does have much easier problems. Some of those were quite a bit lengthy. That's just to really get in some extra practice before you get to the test. Because again, if you can do all of this on your own, you will be just fine for the test. If you stayed this long for the video, I truly appreciate it. I know it's a lengthy one, but I'm just trying to help as many people as possible by showing different ways to do the problems. If you are still listening, just some general advice for test day, just to kind of ease your nerves a little bit. The best thing you can do is go in and just remember your basics. Remember your basics of fractions, adding, subtracting, need a common denominator. Multiplying, you just multiply straight across, and then dividing, you use keep, change, flip. Remember that changing things into sine and cosine instead of their other forms is always an option and will typically get you to the answer. And on top of that, remember, there are many ways to solve all these problems, just like I've shown you here. So if you try something and it doesn't get you anywhere, try something else. And at the end of the day, try something. Don't leave the problem blank. And then as always, general advice, if you try a problem and you get stuck, please go on to the next one and then return to the problems you're stuck on at the very end. I hope this was helpful. If you have any additional questions, feel free to reach out to me via email or come see me in person before your test. Otherwise, I hope you have an awesome day. Bye.